Section 3.4b is about solving multi-step equations. The word multi means more than one. So we're going to have equations that involve more than one step to isolate the unknown. So we're going to have to use addition, subtraction, multiplication, and division all combined to help solve this equation. Remember in the last video we talked about working backwards, and so we're going to do that. As we look here, we want to isolate this q, and the two values that keep the q from being alone are this multiplying by 5 and the subtraction of 13. Well, working backwards in PEMDAS will take care of the subtraction first. How do we do that? Well, subtraction is the opposite of addition, so I'm going to add 13 to make this into a 0. But whatever I do to one side, I have to do to the other side. So rewriting this becomes 5q equals 50. Now the second step I'm going to do, the 5 is connected to the q with multiplication. How do I undo multiplication? The opposite operation is division. Whatever I divide by one side, I have to do the other. So we cancel there, and we get q equals 10. So that's an example of solving multi-step equation. There's two steps actually here, and we did it by working backwards, dealing with addition and subtraction first, then multiplication and division. Here's another multi-step equation to solve. I'm dividing by 12 and subtracting 9. PEMDAS in reverse says deal with the subtraction first by adding 9, doing the opposite. Got to do it to both sides. Next line is x over 12 equals negative 11 plus 9 is negative 2. Now dealing with the division of 12 by multiplying both sides by 12, doing the opposite operation. 12s will cancel. X equals negative 24. Here's an example that's a little special, and it's because this r plus 8 is being divided by a negative 3. So there's a whole group on the top that's being divided. Typically we want to solve this by working in reverse PEMDAS, but in this case I can't even get to the plus 8 that I want to get rid of until I deal with a division, because we're dividing both of these terms by a number. So this is a special case in which you'd have to get rid of the negative 3 first, and we do that by multiplying by negative 3. Why multiplying? Because that's the opposite operation of division. So now the negative 3's will cancel, leaving an r plus 8 equals a positive 6. Negative times a negative is positive. Now getting rid of a plus 8 by subtracting 8 from both sides. So you're going to get r equals negative 2. This is a case where you're not necessarily going to go in reverse PEMDAS, and you'll notice it by a big division bar that divides a large group by a number. Now we're going to talk about problems that involve consecutive integers. Consecutive integers are integers that are in counting order. An example would be the integers 5, 6, 7, and 8. Those are integers that are in counting order. Now one thing to note about those is if you're using those kind of numbers in an equation where you don't know what the numbers are, you're going to treat them as variables. And typically we treat the first one with an n, and then if you wanted to say the next consecutive integer that comes after n, well then you would add 1 to it. Because if n is the first integer, and it doesn't have to be 5, it could be something else, but that means the one that would come after that would be an n plus 1, followed by an n plus 2, and an n plus 3. Now this is important because this is the way that you write consecutive integers when you don't know what they are. Likewise, there's such a thing as consecutive even integers, and those would be things like 8, 10, and 12. Those are consecutive integers that are even, so we skip the odd ones. Now how would we write those if we don't know? Well, we would start with an n, just like before, but instead of adding n plus 1, to get from one consecutive even integer to the next one, you'd add n plus 2. You'd add a 2. And then to get to the next one, you'd say n plus 4. Now here's where it might get a little confusing. Some people don't understand this, but if you're going to do consecutive odd numbers like 3, 5, and 7, again you would start with an n if you didn't know what that first odd number was. But to go from one odd number to the next, what do? You add 2. And then to get from the next odd number to the next one after that, you add 4. Some people get confused because they see these numbers as plus 2 plus 4, those are even, and they think, well, what's up with that? Well, to get from a 3 to a 5, you add 2, and to get from 3 to 7, you add 4. So what I want you to notice here is when you don't know what the consecutive integers are, if they're just consecutive, you call them this, plus 1, plus 2, plus 3, but if they're even or odd, you reference them with an n plus 2, and an n plus 4, and then so on. Now that's important for this next example. It says find 3 consecutive odd integers whose sum is 57. Well, if I have three odd integers, I'm going to say one of them is n. The next one then, if I want to go from one odd number to the next odd number, I add 2, and then to the next odd number I would add 4. Now, the rest of this said whose sum. The word sum means to add, so we're going to add those together, and that is, remember, is equal to 57. So here I have an equation that I can solve, so let's do that. Let's collect like terms. I have an n plus an n plus an n. That's going to give me 3n. And then I have a 2 and a 4 that are on the same side, so plus 6 equals 57. Now you notice an equation that requires multi-steps to solve. Do PEMDAS in reverse, so we'll start by subtracting 6 from both sides, creating a 0. 3n equals 51, and then since the 3 is connected with multiplication, I will do the opposite of that, divide. So n equals 17. Now that doesn't quite answer my question, because my question says 3 consecutive odd numbers. Well, if n is the first one, if 17 is the first one, then the next one is n plus 2, that's going to be 19, and the next one is n plus 4, that's going to be 21. So the answer here is 17, 19, and 21 are 3 consecutive odd integers that add up to be 57.